So far, we've only really thought about dealing with solids when it comes to measuring out a certain quantity of moles or a mass. But obviously, a lot of the time we are dealing with gases. So, how can we extend the ideas of the mole and what we've learned so far into dealing with gases and how they react? Well, it so happens that 1 mole of any gas has a volume of 24,000 centimeters cubed at room temperature and pressure. So it could be oxygen, nitrogen, helium, hydrogen cyanide, whatever you fancy, it will have a volume of 24,000 centimeters cubed. And that makes it really easy for us to deal with gases because it means that the number of moles that we have is proportional to its volume if we keep temperature and pressure the same. So if I have 2 moles of a gas, it will occupy a volume of 48,000 centimeters cubed, and so on. Very easy, and it means that we can form new equations. So these are two important equations for you to be aware of. So it means the volume of a gas is equal to the number of moles we have times 24,000, and we can rearrange that equation to give the number of moles that we have is its volume of gas divided by 24,000. Now when you come on to do this in more detail at A level, we will relate this to the ideal gas equation. But for GCSE, moving into A level, this is how we deal with gases. So let's begin to use these equations. So the first one we'll do is the volume of a gas is equal to its number of moles times 24,000. So let's do a worked example and see how we get on. So we are going to have 1 mole of carbon dioxide. Obviously, number of moles is 1. We times that by 24,000 to give us 24,000 centimeters cubed. Slightly more difficult. Let's say we've got 0.1 moles of ammonia. So that's just 0.1 times 24,000, which is 2,400 centimeters cubed. Now, it doesn't actually matter what gas it is. You didn't know the first one was carbon. You didn't need to know the first one was carbon dioxide and the second one was ammonia. You can just take it for any gas at all. So, how about you have a go at some examples? So there's 0.5 moles of ethene, 2 moles of sulfur dioxide, and 0.12 moles of sulfur trioxide. So I see how you get on with those, and carry on the video when you've had a go. So here are the answers. So you're obviously going to do 0.5 times 24,000, 2 times 24,000, and 0.12 times 24,000 to give you those volumes there. So here's the other form of the equation, just rearranged. So we're going to work out the number of moles now if we've been given the volume of gas that is at room temperature and pressure. So here we go. We'll do a couple together and I'm sure you'll be able to do them by yourself. So let's do, first of all, let's uncover the questions, which we'll do there. And let's do the first one. So 80 centimeters cubed of hydrogen bromide. So it's just going to be 80, which is my volume, divided by 24,000. And that's going to give me 0.003 moles. So let's do one more together. So we've now got 5,000 centimeters cubed of hydrogen iodide. So it's just 5,000 divided by 24,000. And that comes to 0.208 moles. So have a go at the other two. And again, you don't need to know what gas it is, I've told you, but you don't need to know that the first one is NO2 and the second one that you're going to do is F2. We'll carry on with the video when you've finished. Okay, so let's go through that. So we're just going to divide both those volumes by 24,000. And for NO2, we get 0.833 moles. And for F2, 0.018 moles. So we're going to try some more complicated examples now. So we've got to find the mass of the volume of gases stated in the blue box there. So let's just think about the equations that we can use. We've been using the equation for gases. So we've been using this one. Number of moles is the volume of gas divided by 24,000. So we've only got a volume, so we could use that one. And that would give us the number of moles. And of course, we then need to remember the equation that we were using in the previous modules. And that one is, of course, the mass in grams is the number of moles times the relative molecular mass. So what these equations allow us to do is over here we have got the volume which we can put into this equation here. By using this equation we can find the number of moles. The number of moles is then popped into this equation. We can obviously find the relative molecular mass or the molar mass really easily because we've been given the formula there, and that would then tell us our mass in grams. So let's have a go. So we'll take this step by step. So let's do SO2 first of all. So SO2, we're going to find first of all the number of moles. We have our volume there. So we've got 2,000 centimeters cubed of SO2. So we're going to divide that by our 24,000. And if we do that, we will find that we have 0.0833 moles. So we now need to find the number of grams, so we now need to use the second equation. We now know the number of moles that are in 2,000 centimeters cubed of sulfur dioxide. So in order to find the mass, we need to find its relative molecular mass, which we can do quite straightforwardly. We just add up the relative atomic masses of the atoms in SO2, which comes to 64. And after we've done that, we can pop those numbers in the equation at the top there. So our mass in grams is the number of moles, which we've found out, times by the relative molecular mass. So our mass is going to be 0.083. Multiply that by our molecular mass of 64, and that comes to 5.33 grams. So now it's time for you to have a go at the next four. So let's first of all work out the number of moles that we have. So now you've seen a worked example. How about you have a go at doing the next four? So first of all, you need to calculate the number of moles, which you'll do on this slide. So if you pause for a minute or so, and then we'll go through the answers. So hopefully you've had a chance to go through to have a go at doing those. So quite straightforward. It's just the volume divided by 24,000, and by that you get the moles as shown there. So now we have those, we need to pop them into the second equation. So now we found out our number of moles there. All we need to do now is work out our relative molecular masses. So we'll first of all do that. So SO2 we already had. So if you'd like to have a go at doing those, if I pop them out there. So have a go, and then we reveal the answers coming up. Right, so here are the answers for our molar masses. Hopefully you got those okay. And now it's time to pop those in the overall equation. So hopefully you can do that. Give that a go now. Coming up is I'll go through the example for the first one. So the first one is now displayed there. And now let's go through the rest of the answers. So we're going to multiply, to find the mass of the gas, we're going to multiply the number of moles by the relative molecular mass, and that gives us our answers in grams as shown there. So slightly different, we have now been given the masses, and we're going to calculate the volume of those gases. So those in the blue box are the ones that we need to solve. So what we need to think about the two equations that we can work with. So we have got mass there. So let's think about an equation which includes mass. And there it is, where number of moles is the mass divided by the relative molecular mass. So we've got that one. And of course, once we have the number of moles, we can pop that into our volume equation as shown there. So the first thing we need to do is work out the number of moles. So what do we need to do to work out our number of moles? Well, we need the mass, which we do have, of course, but we need to work out our relative molecular mass. So let's do the first one together. So the relative molecular mass of hydrogen is, of course, just 2 times 1, which is 2. So that's nice and easy. And once we've done that, we can work out our number of moles. So again, let's just do that one for hydrogen. So our number of moles is our mass, and we've got 200 grams of it, divided by 2, and that tells me I've got 100 moles of hydrogen. So the next thing there is just to pop that into the equation. Volume of gas is the number of moles times 24,000. So we've worked out we've got 100 moles, so quite straightforward. We're just going to take our 100, times it by 24,000, and that tells me that my volume of gas is going to be 24,000,000, and that's in centimeters cubed. So now it's over to you to work out the rest. So those are the other examples there. So see how you get on, and we'll take it step by step. So if you can do it by yourself without going through the next slides, give it a go, and we'll reveal the answers at the end of the next section. Otherwise, we'll go through this step by step. So in order to work these out, the first thing you need to do is find out your number of moles. So you've got the mass of oxygen there of 240. You find your molar mass of oxygen, O2 there, as being 32. Your mass of oxygen that you have is 240 grams. So 240 divided by 32 gives you 7.5 moles. And so here are the answers for the rest of those. So first of all, we'll do the molar masses. And if you just want to check to make sure you got those right, and then here are the number of moles that you should have found. So now we have the number of moles. It's just up to us to put those into the equation of number of moles times 24,000. So again, let's just do that for oxygen. So we found we had 7.5 moles, times that by 24,000 to give us 1,800,000 centimeters cubed. And so we'll do that for the rest. So let's show those answers now. So it's just the number of moles times 24,000. So hopefully those have gone okay. So just one further example for us to have a go at. So we need to calculate the relative molecular mass now of those gases, and we've been given a mass and we've been given a volume, and they want us to find the relative molecular mass. So we've not done anything like this before, so let's have a think about the equations that we need. We've got mass and we have volume. So because we've got volume, that means we can find the number of moles from that equation. And once we have the number of moles, we can find the relative molecular mass from the top equation there. So the top equation is just a rearrangement of the number of moles is the mass in grams divided by the relative molecular mass. So we're going to use those two equations now to find the molar mass of that first one. So for that first equation there, we've got the number of moles is the volume divided by 24,000. So the volume of this first gas is 56. So that gives me a volume of 0.0023. I know that the relative molecular mass is the mass in grams divided by the number of moles. So I know that the number of moles I've just found out, and I know the mass. So it's 0.373 divided by the moles, and that gives me 162.2. So now it's up to you to have a go at those final three there. So first of all, work out your number of moles and then your relative molecular mass, and we'll go through those next. So let's go through our number of moles first of all. So again, it's just our volume divided by 24,000, and those are the answers there. And once I've got those, it's just going to be my mass, which I found, divided by, which I've got, divided by the number of moles, which I found, to give me those molar masses shown there. So these are the equations we've met so far. We've got number of moles is mass over molar mass, and we can rearrange that to give us a mass in grams is moles times molar mass. And the equation we've met today is the volume of gas is the number of moles times 24,000. So it's really important that you know those equations, so they're at the forefront of your mind, so you can change between the two of them to solve these problems. So hopefully you found that a useful guide to moles and gases. You can download this resource from the website, and please have a look around for other resources And please feel free to message if you like me to do any videos on certain topics you're struggling with at the moment.